Day 55. This is the second review sheet for our minerals chapter. The directions say to draw a line from the statement to the word that fits in the blank, but so that I can zoom in as close as possible to the words, I'm just going to write the letters in the blank. If you want to do the same, that's okay. There's nothing magical about drawing the lines. Number 1. Minerals are not things that are found only in laboratories. All minerals have to be found somewhere in nature. That's what we mean by naturally occurring. If they are only using man-made atoms or man-made combinations, then it is not considered a mineral. Number 2. Minerals are solid at room temperature. In other words, out in nature, in typical environments, it has to be a solid. So lava is not going to be considered a mineral. Water is not going to be considered a mineral, even though it's naturally occurring. It's not normally a solid. Yes, we can make it a solid by freezing it, but that's not room temperature. Number 3. Minerals are something because making them doesn't involve living things. The term living things here is important. Living things make organic materials, and if they are not involving organic, then it's called inorganic. That's option A. Looking over here at the word, the IN means not, and then the organic means living. So these are chemicals that are not made by living things. Inorganic. Number 4. All samples of a particular mineral have the same recipe, or by this same recipe I mean the same combination of atoms and in the same proportions. So if you have twice as many carbon atoms as you do calcium atoms in one of the samples of, let's call it galena mineral, then you're going to have the same proportion in every single sample of that galena mineral. Now please remember that in different minerals, let's say galena and fluorite and pyrite, you're going to have all different kinds of atoms. But for one particular kind of mineral, let's say all pyrite mineral samples, they are always going to have the same recipe, the same combination of atoms, and we call that D, chemical formula. Number 5, the ability to be scratched. That is E, hardness. The harder the material, the less likely it can be scratched. So if it can be scratched by a nail, that means that it is softer than a nail. If it can be scratched by a penny, then it is softer than a penny. If it cannot be scratched by a nail, then it must be harder than the nail. That's how it works. Number 6. Different samples of a particular mineral may have different blank, but the streak, hardness, luster, and chemical composition must always be the same. So in our little activity yesterday, we had, let's see here, what was it? It was fluorite, and different samples of fluorite were slightly different colors, B. Some were more green than others. Some had a lot more white to them than others. But they were all fluorite samples. When we streaked them, they were all the same. When we figure out the hardness, they were all the same. Same thing with the luster and chemical composition. The only thing that can vary between samples of the same mineral is the color of the sample itself. You can think of like diamonds. You can go to the jewelry store and you can buy pink diamonds, yellow diamonds, brown diamonds, chocolate diamonds, all sorts of different diamonds with slightly different colors, but they have the exact same chemical composition, the same streak, the same hardness, the same luster, just different colors. Number 7. Some minerals can be rubbed on tile and leave no streak. I. Number 8. Number 7. It's not common for it to not leave a streak, but it is possible. And remember, the color of the streak might be different than the color of the mineral itself. So yesterday we had green fluorite and we streaked it and the streak was white. And we had bronze colored pyrite and when we streaked it, it was black. Okay, number 8. There are 2 different kinds of breakage patterns that we learned. And number 8 is wondering which breakage pattern is rough and jagged like gravel. The 2 kinds of breakage patterns are over here. They're cleavage and fracture. And the cleavage, that's the one that gets nice flat sides. And you end up with something that looks like a crystal. You might think of it as something that could be mounted on jewelry. Whereas fracture, that's all rough and jagged. It looks like gravel on the side of the road. There really is no flat areas at all. It's all rough. So for number 8 here, it's the fracture pattern. Number 9, what can be described as metallic or non-metallic? That is another category of mineral characteristics, and that is luster, J. We are only going to be learning those 2 categories of luster. It's basically the shininess of the mineral. Metallic is when it looks like there are little tiny flakes of metal in the mineral. Non-metallic is everything else. And number 10, the other breakage pattern has flat sides. It makes it look like a crystal. Looks like a jewel of some sort from the jewelry store. Okay, and that is going to be the cleavage breakage pattern. G. On the back side, a mineral can be scratched with glass, but not a penny. So we go up here and we look at the glass and the penny. If it can be scratched by one but not the other, then the hardness is in between these 2 numbers. So it's between 3.5 and 5.5. That would be option C. Number 12, it can be scratched with a steel nail but not glass. So if it can be scratched by a nail, it's softer than the steel nail. If it cannot be scratched by the glass, then the mineral is harder than glass. So we look up here, and so it's got to be between 5.5 and 6.5. That will be option D. Number 12, option D. Number 13, the mineral can be scratched with everything. So that means that it's softer than everything. And the softest thing that we can be scratched by with our equipment is 2.5. So we don't know how soft it is, except that it's something, a smaller number than 2.5. So for number 13, the answer is A. Number 14, a mineral cannot be scratched with a steel nail, glass, or penny. So that means that it's harder than all of those things. It can't be scratched. It's more durable. It's harder. So anyway, the hardest thing that we have in our equipment is the steel nail with 6.5 as its hardness. So this mineral has got to be harder than that. Something greater than 6.5 Option E for number 14. Number 15. A 50-gram sample of a mineral has a volume of 10 milliliters. What is the density? Remember that the equation for density is the mass divided by the volume. I was going to write down divided. Mass divided by volume. So the mass is 50. And the volume was 10. So we divide that out and we get 5. So option B is our answer. Number 16, true or false? A mineral streak can be different from the color of the whole sample. And that is true. We saw the green fluorite had a streak of white. The bronze pyrite had a black streak. Number 17, the breaking pattern of a mineral is always the same for every sample of that mineral. And that is true. The only thing that varies from one sample to another of the same mineral is the color. If a mineral can be scratched by a fingernail, it is harder than the fingernail. Nope, that's false. If it can be scratched, it must be the softer of the two things. Think of it this way. A nice soft sponge cannot scratch your skin. Your skin is more rough and tough and harder than a sponge. Whereas a steel nail, that is harder than your skin, so that can scratch you. Anyway, that is the end. If you can do all of those on this practice sheet, you will do just fine on your quiz tomorrow. Good luck.